Spanish speaking. Okay, so first of all, let me thank the Scientific Organizing Committee. It's really an immense honor for me to give this talk. I'm really flattered for that. Second, I would like to thank a number of people that have been very helpful to prepare these slides. All the chairs of the scientific working groups of the SKA Observatory have been very helpful. And in particular, Antonio Alberdi, Lourdes Verdes Montenegro, and her team, and very, very especially Teresa Bigert and Javier Moldon have been very useful. So I'm really grateful for that. I have two main goals in this talk. It's actually one goal divided into two sub-goals. First of all is that for those of you who are not, let's say, black belt radio astronomers, that you become familiar with SKA. Oh, that's the main goal. And independently of whether you are familiar with it or not, I see that there is about 1/3 youngsters in the audience, that you become, that you actually be proactive and join some of the scientific working groups. You will see that this talk is also very timely. We have 1 year to go into that SKA train, and you shouldn't miss it. So before we jump into SKA, just very basic thing. Radio emission is not affected by dust. I hope every one of you knows that, but anyway, I don't like to give things for, assume. Top right panel is optical emission, okay? And you will see that the bottom panels in the radio, we see different pictures. Actually, we see everything because we are not affected by dust. This is one very nice property. If you pay attention, the radio emission is not the same in the left panel and the right panel, the bottom. To the left, you see continuum radio emission at 70 centimeter wavelength. And this is the dominant mechanism here is synchrotron radio emission. Okay, it's telling us there is a lot of high energy phenomena going on. And to the right, we have the radio emission from the spectral line emission of neutral hydrogen. And hydrogen is the basic brick of building our universe, and it's very useful to trace the history of our universe. You will see that in a minute. Let me now go into the word, SKA Observatory, so a square kilometer array. Let me focus on the word array here. So why do we want an array when not a very big telescope or a few of them? Well, you see this HST image of Cygnus, the region around Cygnus A. And in the center, we see in all its glory, the galaxy. And we see many objects there, beautifully, the resolution, the angular resolution is very nice, so we can really pick up, okay, the optical emission comes from this object or this other one. Well, imagine, now this is a 2.5-meter telescope in the optical. If we had used a 100-meter telescope in the radio, not 2.5 meters, the whole image would be just one single pixel. So you see, we have no resolution, even 100 meters. It's of no use to attribute where the radio emission comes from. So that's why, some smart radio astronomers invented radio interferometry. Well, interferometry was known, but radio interferometry. And radio interferometry allows us to go from that to that image. But actually, using an array of radio telescopes, we can now know that at the center of this galaxy, there is a supermassive black hole ejecting, being responsible for the ejection of relativistic jets. We know now, we have a beautiful image that we can compare with the optical. So this is why array is needed here. The other thing is a square kilometer. Why do we want a square kilometer of collecting area? Well, for that, I have to go back to the 90s. You have to now to tune your radio to listen to SKA music, not SKA, but SKA music. So back in the 90s, early 90s, there was a meeting, a very nice conference in 1991, where ideas for new groundbreaking instrumentation was put forward. And it was Peter Wilkinson and I guess other people. At the time, I was very busy doing my undergraduate studies. No, just a spoiler about my age. So the point was that in this contribution by Peter Wilkinson, he put forward the idea that if we would like to make a jump into into studies in astrophysics using radio interferometers, 1 square kilometer array was needed of collecting area to really be very sensible, to go from redshift 0 to redshift of about 10 and study the neutral hydrogen emission. So actually that was why the hydrogen array as you see here came along. the SKA initially was called the hydrogen array because the main goal was thought of the, start tracing the neutral hydrogen. But of course, with such a collecting area, it was very possible to do a lot of science. For example, he also mentioned pulsars, testing Einstein's theory of relativity and other things. So think about the SKA like the 4 ones. 1 square kilometer array of collecting area, which will have a 1 second angular resolution and a sensitivity of 1 microjansky at 1 gigahertz, or 30 centimeters, okay? Remember those values because they're going to be very useful. Well, radio astronomers don't know that, all of you radio astronomers, but the rest, they always complain, well, microjansky, what the hell is this? Well, we complain about magnitudes or millimagnitudes, so. Now, what is the status of the SKA observatory now? So you see here the web page, you can go invited to go there. It's basically the observatory 2 telescopes. One working at mid-frequencies, SKA mid, and the other one working at very low frequencies. So SKA mid is basically like almost 200 dishes, the standard telescope we all think of, that can be moved. And it will use this telescope will use the already existing 64 telescopes of MERCAT, which is a SKA precursor, will be put in South Africa, in Karoo, and will work at wavelengths, here is in Earth, so from 350 megahertz up to 15 gigahertz. For you, just is this something from 2 centimeters and up to 90 centimeters wavelength, okay? But this we call mid-frequencies. And the maximum baseline, the array will go up to 150 kilometers. So we'll have a very nice angular resolution, even better that 1 second at some frequencies. The other telescope will be put in Australia, in Western Australia. We'll have more than 130,000 dipole antennas. So, it will work at even lower frequencies, from 350 megahertz down to 50 megahertz, or from 90 centimeters to almost 11 meters. And you will see in a minute why that's necessary. It will have eventually up to 74 kilometer long baselines. And let me now switch to some of the topics that will be tackled with the SKA observatory. Let me start. Basically, this is a correlation with the existence of science working groups, okay? I will tell you what is this in a minute, but for you to know. So, as I mentioned, hydrogen array. Well, the basic idea here with this telescope at very low frequencies is to probe the epoch of reionization and beyond, the cosmic dawn in the universe. And actually, it's because using the SKA low, one of these 2 telescopes, we will be able to go from redshift up to redshift 26. So it will be possible by tracing hydrogen at these very early ages of the universe when we had galaxies to trace when this epoch of reionization, to date it very precisely. So that's the main goal. Another very interesting topic is the cosmology and galaxy evolution. This is 2 different groups, but basically the idea is also the same. They will use neutral hydrogen to be traced from redshift 0 up to redshift 6 to basically study how the universe evolved in the last 12.8 billion years, and using hydrogen, that's made. But of course, with this telescope, it will be possible also to study things like the star formation across the universe and AGN feedback. So this is also very, very, very important topics. I mentioned pulsars. One of the main things with this SKA low and SKA mid will be to test theory of relativity of Einstein. Thousands, something like 20,000, even if not more, pulsars will be the question of time. Pulsars are very, very precise clocks, and they will suffer these tiny distortions when gravitational waves pass in time. So that's a very smart idea. This group, or this topic that I am now about to mention, was not even thought of 15 years ago. This is a very beautiful image of the galactic center taken with MERCAT, the SKA precursor, where this SKA mid will be located in South Africa. So things like studying the life cycle of matter, the baryons in our galaxy, is one of the main topics. And the other one is the obvious thing. We have at the center of the galaxy, we have the closest supermassive black hole. So it's obvious to study it and what will be its impact on galaxy evolution. By the way, if you are interested on the galactic survey, there is Rainer Schödel from our institute led a paper, I'm a collaborator of it, where this is a white paper for SKA Galactic Center Survey with SKA. And this is a good idea of actually put forward, position yourselves in the SKA land. So you can also do that. Cradle of life, or basically how do pebbles turn into planets? Or things like, are we alone in the universe? So there is a very active group, the SETI, Search for Extraterrestrial Intelligence. Topics like direct detection of Jupiter-like planets, and measure the magnetic field will be possible at SKA low. This is not possible now. This will be possible with SKA. Sorry, I'm going a bit fast, but just I want you to have a flavor of the science, not really to become a black belt cosmologist or anything. The last two slides about these science things. Well, a very important topic is also cosmic magnetism. To actually trace, when did the universe become magnetic and how it has evolved through time? This is the main goal of this science working group. What will be the tools? Basically, they will use Faraday rotation, the fact that synchrotron emission is polarized, like here in those clusters that you can see, galaxy, cluster of galaxies, and also Zeeman splitting. Okay. And the final, but I'm not being exhaustive here, is the transit the sky, just because I've been also very active in this field. You probably heard about fast radio bursts. We still don't know what the hell are they made of. Still, we are using them to probe, as cosmological probes. It's pretty much the same like using Taiwanese supernovae to actually measure the acceleration of the universe, but having no idea what a Taiwanese supernova one is made of. So we would like to know that. Yes. We are also curious people, right? So again, they are using H1. Now let me switch to the, that was unavoidable. I'm sorry, but nothing compares to you, right? So a bit of promotion of SKA, and some people ask me, so why are you still working on your presentation? Well, I didn't know yesterday what was be the outcome of that. But then, well, definitely SKA does better than the previous current instrumentation. Right? So, okay, well, jokes aside, so to the left you see a sensitivity plot. Just compare the curves. So the blue curve, don't forget about the magenta for the moment, compared to other state-of-the-art current rate interferometers. The factor of insensitivity, the gain is about typical factor of 5 at essentially any frequency from the lowest ones from 50 or 70 megahertz. Sorry, I'm from 11 meters even up to 2 centimeters wavelength. I keep forgetting that most of you are not radio astronomers. Sorry for that. And the idea is that this will save a lot of time, of integration time. So now you look at the right panel. This is the survey speed. Basically, how effective is your telescope at covering a certain area of the sky in a given amount of time down to a level of sensitivity. It will be something like a factor of 100 better. You will be able to carry out surveys that you cannot even think of right now with the existing radio interferometer. So I hope this will convince you that you better have a look at what SKA can do for you. Not what you can do for SKA, but the other way around. Okay, so this beautiful slide provided by Javier Moldon, it's a bit, let's say, complicated. So it's angular resolution in the y-axis versus wavelength. In the upper is in frequency, physical scale. Well, the point is here, if you look for a SKA low and mid, it will nicely cover a gap in resolution. Remember these 4-1 rule I told you. So one second angular resolution at 1 gigahertz is there, but you may see that maybe the angular resolution of existing VLBI arrays are even better, even LOFAR. Actually, it's LOFAR VLBI. So LOFAR VLBI uses arrays that extend up to several thousands of kilometers, and that's why the resolution is so good. Well, here SKA1 and mid low are without this VLBI, but there is the idea of actually using also VLBI arrays in conjunction with them, as we've seen today, the image of the Event Horizon Telescope, which actually combines not just ALMA, but an array of radio telescope, and that will basically match the resolution that you see down, the EVN, which is the best, the state of the art in terms of angular resolution in our planet. So that looks very, very nice. Now let me switch a bit back to 2014. So the story was like that. In 1999, there was the first contribution, there was a call for ideas of what science what the community would do with such a square kilometer array. And I remember, I was about finishing my PhD, and I was asked to write a small chapter, just what supernovae with the SKA. So I did this with John Marcaire and Anton Alberti in collaboration. And, but 15 years later, of course, things had changed completely, and the SKAO asked for, a proper contribution from the whole community. So there was this very nice meeting in Giardini Naxos in Italy in 2014, and the result was this 2-volume book. I wrote a chapter, or I led a chapter on Coccola supernovae, type 1A supernovae at the time, 2,000 pages, 135 chapters, more than 1,200 contributors, and 8 kilograms of book. This is not the kind of books that you carry to the beach, to sunbathe and read it. It's really 8 kilograms. Okay, just remember that. And at the time, there was only 8 science working groups that you can see listed here. Okay, and basically the science reflected what was the interest of these science working groups. So the current situation, and you have here the link, is that there are 14 science working groups. We don't expect this to rise beyond that number. So the point is that if you are interested, you should actually go to those pages, have a look at the science that is closest to you, and simply write to the chairs. It's organized like that. There are 2 chairs, normally one man and a woman per working group. You contact basically 2 of them, and I say, well, these are my interests, and I think this SKA could be of use to me, and they normally accept you because it's free admission, basically. So for the moment, just be here. Things can change. So then you can become an associate member. Now, if you want to become more engaged into that, you can ask to become a core member. So the core members and the 2 chairs, they meet regularly, once per month. Let's say they have minutes, and these things are then, in principle, they should be made available to everyone. But I must tell you that some groups work better than others. I'm in a few of those, and I know that. But be proactive here. Be proactive because, of course, the alternative is, I am not interested in SKA. It cannot do anything for me. Well, okay, then sit and just have some chips and enjoy your dog's company. That's an option. But I'm pretty sure you can find something that interests you, and you can become proactive. So maybe some of you are not, I don't need you to convince of using the already existing SKA precursors and pathfinders. So precursors are basically the telescopes that were initially devoted to become part of SKA. These are the four ones in the top part. So ASCAP was the idea of the SKA meet put forward by the Australians, but in the end, it's going to be MERCAT. But you can apply for ASCAP or MERCAT. They have open calls, and you are very quick. Right after you end, I finish my talk, you go there and prepare, you type your proposal for the MERCAT, which I think the deadline is in 2 hours or 3 hours from now. Well, jokes aside, in the bottom part, the 2 lower rows, you see a lot of instrumentation that is really very, very good. They have, again, open calls, and you are more than welcome to propose as a preparation for SKA science. Now, again, this slide is an updated version from one by Javier Moldón, which I found very useful, so he was kind to let me use it. I don't intend you to explain this in detail, just as a refresh that there are low frequencies and mid-frequencies. Here, you see the resolution and sensitivity in microjanskis for 1 hour integration time. SKA typically will reach one microjansky instead of, let's say, the 5 or 10 here, so the factor I told you about. You don't have to memorize those numbers, just compare them. So, SKA will be better, but this is the best you can have access to right now. So you can go there and say, okay, I maybe need for my science this angular resolution and this sensitivity. There are available sensitivity calculators. You don't have to be really a great expert, but of course, some minimum knowledge of radio astronomy, but you know that. You've been to these master courses, so most of you know that. Or just approach, the closest radio astronomer. We are in the audience very helpful. So Yeah, and sorry for this is a bit of too much in that slide, but these three blocks. What is Spain? No? Spain doing in this Escalant, where we have a web page, SKA Spain. Lourdes Verdes Montenegro is the leader of this effort. She started already more than a decade ago with a main goal that in the end Spain would enter the Spain as a country. The consortium, the SKA Observatory Consortium that we did last June 24 was the signature of agreement, so very recently. We are now a full member of SKO, so proposals are again welcome. By the way, if you have any news related to SKA or you have some questions or even so, I think that you can directly approach any science working group. If you have any doubt, please contact SKA Spain. Go to the webpage and find there. Okay, but when did this start? Well, this thing already started in 2014 when we decided that it was a good idea to engage the community. So we made a call for, let's say, proposals for chapters to write our own Spain SKA white book that we did. I was the editor-in-chief at the time, but you know, of course, I'm very thankful to all the people that contributed. More than 30 chapters and more than 120 researchers from Spanish institutions contributed. Currently, we are 65 people in the SKA science working groups. 20 of them are women, so well, a bit less than a third. But again, I think we encourage that, you know, participation of women and equality, or SKA has also this gender balance. You see that we participate in 12 out of the 14 existing working groups. I'm a bit surprised that there is now no one from the gravitational waves. There were 2 people, but they were Italian and they moved to Italy. So I think it would be a good idea, you know, to promote that. Solar ionosphere also have no representation, and some of them are just minimal. But you know, some of them in other groups we have a lot of people. Yeah, I'm a bit behind. We have now to change the paradigm. Probably that applies to all telescopes right now, but the data will be humongous. Every year, something like 600 petabytes will be produced. This is just unthinkable of doing in any computer. So there will be no raw data available to the user. There will be science-ready data products that will be provided to the users. There will be no local data analysis. It will be impossible. So it will be done in the so-called SKA regional centers. Okay? And the vast archive that will be available will be also in those centers. So actually, there is a global network of these centers, the SRC net, and don't think about Skynet or something like that. The SRC net is the SKA regional centers network. Okay? That's where all the processing will be done. Spain has been very proactive, and the SKA Spain actually, well, they put this idea of hosting and a prototype of the SKA regional center. It is hosted in the Instituto de Astrofísica de Andalucía. The main goals are, of course, maximize scientific return, participation of Spain in SKA science projects, and facilitate preparatory SKA science. I'm showing you here just a representative sample of ongoing research projects that, thanks to the computing support facilities that we are provided, and of course the support by the great people that work there, we don't have to care about installing software. You see, I need that software. It is installed. This doesn't work. They fix it. And we have been able, or the SPSRC has been able to actually host a large number of projects that make use of these SKA precursors that I just told you in a minute. I'm running out of time, but no, I have 1 minute, right, or 2 minutes? But you may think, well, but this thing of SKA, you didn't show any telescope. Well, here it is. Last July 4th, the first telescope was erected in Karoo, the one to the right, top right. This is dish 1 of the SKA. Of course, the other 64 dishes of MERCAT that you see in the black squares in the bottom panel to the right are already there and working, but they are not part of SKA so far, because we have to wait for our own SKA dishes to work. And the construction of other dishes is ongoing, like the dish number 4 being constructed and erected in China, waiting to be moved. Please attention to this graph. These dates are very important. So the start of science commissioning will start very soon this year, or very early next one. Start of science verification will start in 2027. What does this mean? Well, that all the data will become public immediately for everyone to use it. So from that, and of course, you shouldn't wait for 2027 to start downloading the data or do something. You have to prepare towards that. And then in the period of 27 to 29, there will be call for proposals for key science projects, and only in the 2030, they will start this project. So actually, SKA will become a reality when fully operational 2030. Okay, you may think this is a lot of years. Well, there's certainly not for the young people. Maybe if one is about to retire, you say, well, what the hell with that? But no, don't think about that. Be really proactive and make use of it. So after the meeting in 2014, save those dates also too. Next year, there will be a meeting in person, 16 to 20th of June in Görlitz, which I've been told is a very nice city. And I think many movies have been made there. Virtual attendance will be fully supported, so in case you cannot go in person, I really recommend that you follow all the talks. And the main goal is to update the SKA science book that was written 10 years ago. There is been a call happening right now. I mean, when I say now, it's last week was that. For this month and next month, most of these science working groups are making that call, collecting ideas for drafting chapters. So groups are currently now being formed to write those chapters that will have to be delivered, at least the drafted version, by January 2025 to be on that book. So definitely, if you want to have some minimum contribution or leadership, you have to be there. If not, you are missing that trade. And I've been, everyone says, and that's true, that leadership by early career scientists, young people, is being promoted. So if you are in a very good position, if you are a young postdoc or about to end your PhD and you have made some contribution that is SKA related, because you can basically say, hey, I'm young and I would like to lead that. And you will probably have good chances of doing this. The SKA is now providing tools to do these simulations. So you go to that web page and you get help. And just because I'm running out of time, and this is my last slide before the summary, I would like to encourage you that to go to that Wednesday special session. Unfortunately, it's a lunch session on the SKAO. So things like this, those tools will be discussed. I also, as you see here, there is a lot of contributions of SKA, so many people are, although there is not a proper, let's say, symposium, there is a lot of SKA going on in the talk, so please have a look at this if you are interested. And with this, just, the takeaway messages. In case I haven't said this enough, I think the prospects for SKA look now splendid, finally. There was a time when I was thinking, well, maybe it will not become a reality. Now I do believe. I'm really a SKA believer. And we should continue, all of us, to start using the current precursors and pathfinders. And definitely, you should join one of these SKA science working groups. Science will be done from there and outside. Then the SKA's Spanish prototype of an SRC is working beautifully. It's fully operational. So you need, I have an idea, just please contact them. And finally, don't miss next year meeting. So I'll stop here and maybe have 1 minute for taking questions. Thanks a lot.
Exactamente 1 minuto para alguna pregunta de 1 minuto.
Okay, thank you. Well, I don't know whether to ask this question in Spanish or English, whether you prefer. Okay, whatever. Yeah, so if I understood correctly, in the SKA law, the peak sensitivity is around 70 centimeters, right? Like 400 megahertz or so.
Yeah.
Yeah. So has there been any study on the potential impact of radio interference in that band? Because that band is mostly used for downlink of satellites, particularly the ones you would find in near-Earth orbits, which currently, with all this trend of the new space and all that, right, are going to be particularly bright in the sense of regular transceiver level of bright. And that's it. Thank you.
Well, thanks. Yeah, so definitely there is radio frequency interference, not just in that band, in many of those bands, and this is being taken into account. So, of course, there is the nice thing is it's going to be a continuous, coverage of frequencies from, let's say, 50 megahertz up to 15 gigahertz. But of course, there are regions where there will be a lot of RFI, and that will be, basic, you'll do your best, but that's also why in the SKA law is put on a very far away site in Western Australia. There is nothing around in many, many kilometers. You better go there with a lot of water. Yes. I mean, the satellites will be, so this will be, let's say, corrected, removed. So there will be specific parts that will need to be removed, but, that to minimize what I mean is RFI, that's why we put really, really aside.
Okay.